The universe is filled with objects so enormous that the human mind struggles to understand their true scale. Planets are big. Stars are bigger. But beyond them exist structures so massive that even entire solar systems disappear inside them like grains of sand. Our home galaxy, the Milky Way, contains hundreds of billions of stars. It stretches across more than 100,000 light-years. For most of human history, we believed this galaxy was the entire universe. But as telescopes improved and our view of the cosmos expanded, astronomers discovered something shocking. The Milky Way is not special. In fact, compared to some galaxies out there, it is relatively small. Far across the universe lies a colossal cosmic structure known as IC 1101. A galaxy so enormous that if it replaced the Milky Way, it would stretch far beyond the boundaries of our local group of galaxies. It is one of the largest galaxies ever discovered, a city of stars containing trillions upon trillions of suns. But galaxies are not the only giants in the universe. Hidden deep inside many galaxies are objects even more mysterious and far more terrifying. Black holes. These are regions of space where gravity becomes so powerful that nothing, not even light, can escape. Most galaxies harbor a massive black hole at their center, quietly controlling the motion of stars across thousands of light-years. Our own galaxy contains one called Sagittarius A star. But Sagittarius A** is tiny compared to some of the monsters astronomers have discovered in distant parts of the cosmos. Some black holes grow to unimaginable sizes, billions or even tens of billions of times the mass of our Sun. And among these titans is a black hole so massive that it pushes the limits of what scientists once believed possible. A gravitational abyss capable of dominating an entire region of space. Which raises a fascinating question. What happens when we compare two completely different cosmic giants? On one side, a galaxy so enormous that it contains trillions of stars. On the other, a black hole so powerful that it can bend space and time itself. Which one is truly bigger? Which one is more powerful? And what would happen if these two titans existed together in the same place? To answer these questions, we must journey across billions of light-years, explore the largest galaxy we know, and confront one of the most extreme black holes ever discovered. This is the story of IC 1101 versus Phoenix A star, a comparison between two of the most extraordinary giants in the entire universe. And by the end of this journey, you may realize something astonishing about the true scale of the cosmos. About 1 billion light-years away from Earth lies an immense cluster of galaxies called Abell 2029. At the center of this cluster sits an object so enormous that it dominates the entire region. This object is IC 1101. IC 1101 is not just another galaxy. It is classified as a supergiant elliptical galaxy, one of the largest types of galaxies known to exist. Its diameter is estimated to be around 400,000 to 500,000 light-years. To understand how large this is, consider our own galaxy. The Milky Way is about 100,000 light-years across. That means IC 1101 could be 4 to 5 times larger. If this giant galaxy replaced the Milky Way, its outer edges would extend far beyond the region where our neighboring galaxies exist today. But its size is not the only astonishing thing. IC 1101 may contain trillions of stars. Each one of those stars could have its own planets, moons, and possibly even life. Yet despite its unimaginable size, IC 1101 did not form this way. Like most galaxies, it grew slowly over billions of years. Galaxies often collide and merge with one another. Smaller galaxies fall into larger ones, gradually increasing their size. IC 1101 likely consumed many smaller galaxies over cosmic history, becoming a giant through countless mergers. It is essentially a cosmic city built from billions of destroyed galaxies. But something else hides at the center of this enormous structure. Something dark, something powerful, something that exists inside almost every galaxy. At the heart of most galaxies lies an invisible monster, a supermassive black hole. Unlike the black holes formed from dying stars, supermassive black holes contain millions or billions of times the mass of our Sun. They sit quietly at the center of galaxies, controlling the motion of surrounding stars. The Milky Way's central black hole, Sagittarius A*, has a mass of about 4 million suns. That may sound enormous, but in the universe of black holes, it is actually quite small. Some supermassive black holes grow to billions of solar masses. These giants form through several possible processes. They may begin as the remnants of massive stars in the early universe. Over time, they grow by consuming gas, dust, and even entire stars. When galaxies merge, their central black holes may also merge, forming even larger monsters. This process can continue for billions of years. Eventually, some black holes grow so massive that they dominate entire galaxy clusters. And among these extreme objects lies one of the biggest ever discovered. A black hole linked to the distant Phoenix cluster. Deep inside the Phoenix cluster lies a galaxy containing one of the most extreme black hole scientists have ever studied. This object is known as Phoenix A. Its mass may reach tens of billions of times the mass of our Sun. That makes it one of the largest black holes known in the observable universe. But what makes black holes truly terrifying is not just their mass. It is their gravity. Black holes create a boundary known as the event horizon. For a black hole as massive as Phoenix A*, the event horizon itself could stretch across an enormous distance. Entire solar systems could disappear inside it without leaving a trace. Yet black holes do not behave like cosmic vacuum cleaners. They do not randomly suck in everything nearby. Instead, their gravity works just like any other massive object. If our Sun were replaced with a black hole of equal mass, Earth would continue orbiting normally. The difference is that Phoenix A** is so massive that it can influence matter across enormous distances. Gas clouds spiral toward it. Stars can be torn apart by tidal forces. When matter falls into the black hole, it heats up and releases enormous amounts of energy. These powerful emissions can sometimes outshine entire galaxies. But even a black hole this large is still very different from a galaxy. Which brings us to the ultimate comparison. Now we arrive at the central question. How does a giant galaxy compare to a massive black hole? At first glance, the answer might seem obvious. A galaxy like IC 1101 contains trillions of stars spread across hundreds of thousands of light-years. A black hole like Phoenix A is much smaller in physical size. But the comparison becomes more interesting when we consider mass and gravity. Even though IC 1101 is enormous, most of its mass comes from stars spread across huge distances. Phoenix A*, on the other hand, compresses unimaginable mass into a tiny region. This gravity can warp space itself. Yet even the most massive black hole cannot swallow an entire galaxy instantly. Galaxies are simply too large. Stars orbit the galactic center across vast distances, often far outside the black hole's direct influence. But imagine something extraordinary. What if Phoenix A** existed inside IC 1101? The black hole would dominate the galactic core. Stars wandering too close would be torn apart. Gas clouds would spiral inward, forming blazing accretion disks. Over millions of years, the black hole could grow even larger. But even then, IC 1101 would remain a colossal galaxy. Because galaxies are far more than the black holes at their centers. They are entire ecosystems of stars, dust, dark matter, and cosmic history. When we compare IC 1101 and Phoenix A**, we realize something profound. Even the largest galaxy and one of the biggest black holes are just small pieces of a much larger cosmic structure. IC 1101 itself is only one member of the Abell 2029. Galaxy clusters can contain hundreds or thousands of galaxies. And beyond galaxy clusters lie even larger structures. Cosmic filaments stretch across billions of light-years, forming a vast web of galaxies throughout the universe. In this enormous cosmic web, galaxies like IC 1101 are merely glowing nodes. Black holes like Phoenix A** are just tiny points of darkness hidden within them. The universe is so vast that even its giants are small in comparison. Yet these cosmic titans help astronomers understand how the universe evolved. By studying massive galaxies and enormous black holes, scientists uncover clues about the earliest moments of cosmic history. They reveal how matter gathered, how galaxies formed, and how gravity shaped the cosmos. And perhaps most importantly, they remind us of something humbling. Our planet is just a tiny world orbiting an ordinary star in a fairly normal galaxy, in a universe filled with giants beyond imagination. Somewhere out there, galaxies larger than IC 1101 may still exist. Black holes bigger than Phoenix A** may still be waiting to be discovered. And every new observation pushes the boundaries of what we believe is possible. The universe is far stranger, far larger, and far more mysterious than we ever imagined. And we are only just beginning to explore it.